Hi, my name is Ari Everett. This is for class CSC120, Professor Cody Anderson in the fall of 2023 at Mesa Community College. This is week 0, demo 0, and we are learning how to use the basics of a microprocessor in Logisim. I used the suggestion to write out a script and practice the demo, so forgive me if I sound a bit robotic. Let's move on. This basic microprocessor was provided to us by the teacher here in Logisim. First, I'd like to explain the broad components of register transfer, which is a main theme for takeaways on this course. Register transfer is the moving of information from one register to another. There are 3 basic components and elements to a register transfer, and those are the processor, you can see here, the memory, which is our ROM and RAM here, and the data bus, which are these wires flowing between all those components. The processor is what controls the operations to be done, like selecting registers or performing operations within the ALU. ALU stands for Arithmetic Logic Unit. The ALU performs tasks, and we can think of that like a calculator. You can see some of its functions here: 0, 1, 2, 3, subtract, add, multiply, and multiply. And finally, its memory is the second component. That's down here, read-only memory. Memory are devices that hold data and bits in this case, which stand for values. They are used for data memory and data movement. And finally now, the third main component is data bus. So that will run the information between components of the circuit. So these are these wires coming from the processor out to the memory and then back over to the processor. Now let's do the demo outlined in the instructions from the teacher, which is to use this microprocessor to get data from the memory down here, push it to the processor, perform a function subtraction, and then send it back to memory and store it within RAM 6. This will be 8 minus 3 equals 5. So let's do those steps now. First, we'll set ROM 0 to the value of 8, which is binary 1000, 1000, and ROM 1 to value 3, binary 0011. We'll set write to 0, which it currently is, and read to 1. It's because we're reading the values first from our read-only memory here in ROM. You can see the green wires highlight that. Change the address input to address 1, which is 001. You can see the green wire highlights towards ROM 1. This is like an address selector or director. It chooses which one of the memory components we want to point to and pull from. Make sure the switch A or B is set to 0. If you set it to 1, you can see the information will flow up here in the 1 bank. We don't want to do that for now. We want to set it to B, so we want to let it flow through B. Now we'll set enable B to 1. This is so that the data will flow through store B here instead of stopping there. It will flow through and out to the ALU. Now I will run the clock manually by flipping the clock input up and down once here, and this will push the values of store B to change. So watch this number here. Boom. We'll turn the clock off, and now we'll go to the next step. Now we'll set enable B back to 0 because we want to go through the store A route, and we'll set the address down here to 0. You can see the wires change, and we'll be pulling this 8 value, binary 1000, from ROM 0. And we want to route this up through the A side now. Now to make sure that goes to the A side, we have to go back to the switch A or B and set it to 1. You can see now the 1000 binary, which is 8, is flowing to the A side. Now we're going to set the ALU to do the operation that we want with this select button. You can see it's set to 1 right now. 2 is for multiply, 3 is for multiply, and routes goes back down to 0 to subtract. Let's leave it there because we want to do subtraction. Now we want to set enable accumulator. Similar to the enable B switch here, this will enable data to flow through to the accumulator and execute there. Now I'll run the clock manually again. Watch this number here in accumulator as we have this 3 here and the 5 or the 8 up here running through A, it will both be pushed through the ALU, the operation performed, and there should be a 5 that runs through here. Here goes the clock, and back down. This accumulator did indeed turn to 5. But we're not done yet. The instructions asked us to take this 5, the output value, and push it down the data bus and store it into RAM 6. So here's how we're going to do that. First, we'll make sure to set enable accumulator and enable B back to 0. This is already 0. We're going to set read to 0 because we're no longer reading information from the ROM. We're going to be writing this to the RAM. Now we need to change the address selector to 110, which is pointing towards RAM 6. We can see that highlighted here in this green wire. Now we'll set this accumulator out switch to 1. This is similar to the enable accumulator and enable B as a function to allow data to pass through a accumulator buffer through the data bus and into our location of choosing, which is RAM 6. We can double check the information flowing through the data bus right now by clicking on it. We can see that it's binary 0101, which is the value of 5 that we got from our operation up here. And so now for the final step and the quote-unquote magic to happen and write this into RAM 6. We'll run this clock and everything I mentioned should happen here. We'll be pushing this 5 enabled accumulator out through the data bus, down through the address selector, which has selected RAM 6, and store our value of 5 in RAM 6, currently to 0. So watch this RAM 6 0 turn into a 5 as I manually switch the clock. Boom, and there you have it. Oh, it's magic.